Alright guys, so we are taking a quick look and reminder, or if you weren't here last time, some notes on geometric recursive equations. Okay, so remember, geometric pattern is one where we multiply or divide. Okay, arithmetic are the ones where we add or subtract. Okay, but with recursive equations, they're very similar. Okay, so the idea here, right, is if we have a pattern here. Say we start with 10, and then we go to 20, then 40, then 80. Okay, the idea to get that next term, right, with recursive, is we take the previous term, so that 80, right, to get the next term, the fifth term. We use that fourth term, which is 80, and then we apply the growth to it, which in this case is multiplying by 2. Okay, and that would give us the next number, which would be 160, right? Okay, but we also need to have that first term. Okay, and when we say first term, I really should call it probably the zero term, because we're talking about this guy, not the first term down here. We're talking about that guy. So going backwards, that would have to be 5, right? Because 10 divided by 2 is 5, or in other words, 5 times 2 is 10. So the way we write that is a sub n stands in for next. A sub n minus 1 is the previous. Just like to find the fifth term, we had to use the fourth term, which is minusing 1. And then multiplied by the growth, right, because we're doing geometric. Then a sub 0 equals that starting number. Again, we can use the f of n version. It's basically the same thing, but we'll focus more on this one. Now, the only difference between this geometric and the arithmetic version is the arithmetic just has a plus here or a minus there instead of a multiply. Okay, everything else is pretty much the same. Okay. Alright, so let's take a look at a few examples. So if we have a pattern, right, we see we've got 5 squares there. Then notice we have 5 more, so that'd be 25. And then 5 more of those 25s, right? Which would be 125. So, what are we doing? Well, our constant ratio, right, that's the growth number, okay? When we say the growth is pattern, it's the constant ratio is the official name for it, or the CR we could say. Okay, our CR equals, what are we doing each time? We're multiplying by 5. Okay, so I know I'm going to go a sub n equals a sub n minus 1, and then times 5. Okay, make sure we're not going times 5 this way, because I don't know if you mean that for a variable or if you mean multiply. So if you're not doing the dot, you got to do the dot. Okay, then we need the zero term, or the start number, okay, that a sub 0, because that tells us it's the zero term. So to do that, we've got to go backwards, right? Because we've got the first term of 5, the second of 25, the third term of 125. So going backwards to the zero term, what number times 5 would equal 5? Well, it's got to be 1. If you said 0, remember, anything times 0 is 0, so we'll never have the 0 there. It just won't work. Okay? So we get 1 for our starting number. So a sub 0 equals 1, and there's my recursive equation. Okay? Alright, now what if we just have a sequence of numbers? Okay, well again, same idea. We're looking for the constant ratio and the zero term. Okay? But I know on all of these, I'm going to start out a sub n equals a sub n minus 1, and a sub 0 equals. Right? Every single one of these, I know it's a sub n equals a sub n minus 1, and a sub 0 equals. Okay? Again, a sub n equals a sub n minus 1, and a sub 0 equals. And in all of these, we need that constant ratio and the starting number, the zero term. That constant ratio and that start number, or that zero term. Okay? So, looking at this first one, I got -2 to -4 to -8 to -16. should notice we're timesing by a positive 2. You may want to say a negative 2, but a negative times a negative would be a positive. And notice this one switches, so keep that in mind when we look at that next one. Okay, but I'm timesing by 2, that's my constant ratio. Okay, so if I go backwards, what times 2 would give me negative 2? It's going to have to be a negative 1. That's my 0 term. So 0 term goes with the a sub 0 equals, constant ratio goes right here, and times by 2. Okay, now I look down here and I see negative 1 to 2 to negative 4 to 8. Okay, I know I'm timesing by 2, but I should also notice, how do I get from negative to positive, positive to negative? Timesing by a negative 2. Okay, so my constant ratio is I'm timesing by negative 2. Okay, so going backwards, what would be negative 1 divided by negative 2? You got it. It would be a positive 1/2. I could put 0.5 as well, but I like to keep it as a fraction. So my a sub 0 is 1/2. A sub n minus a equals a sub n minus 1 times by a negative 2. Okay. If I look at the next one, okay, how's it growing? Negative 1 to negative 5 to negative 25 to negative 125. Times them by 5 each time. It's my constant ratio, my growth. Okay, then going backwards, okay, again, negative 1 divided by 5 would be negative 1/5. So that's my starting number, which is negative 0.2, I believe. So, times by 5 here, start with negative 1/5. Because we get that a sub n equals a sub n minus 1 times the constant ratio times the growth, and a sub 0 equals our start number, our 0 term, and it looks like that. Okay. Alright. We've got another one that goes negative to positive to negative to positive. That tells me that I'm going to be multiplying by a negative number each time. Okay. So my constant ratio is times a negative what? Well, 2 to 6, 6 to 18, 18 to 54 should key us into that we're timesing by a negative 3. Okay. Then my 0 term, my growth or start number, going backwards, negative 2 divided by a negative 3. Negative over negative makes a positive. I could just write it as 2/3 for my start. So I go, my next number, a sub n, equals my previous number, a sub n minus 1, times my constant ratio of negative 3. That's the pattern. Where does the pattern start? My a sub 0, my 0 term, is definitely 2/3. Okay, now maybe you see a problem. Let's make one up. Okay, let's say we see something like this. We see 81, 27, 9, 3. Okay. So if I'm looking at this one, notice I'm starting with bigger numbers and going smaller. In this case, I'm dividing by 3 each time. Okay. And so if I'm going backwards, I believe that's 243. So my 0 term, my a sub 0, is 243. And my growth is I'm dividing by, my constant ratio is dividing by 3. So in the recursive, I'm okay if we write divide by 3. However, when we deal with geometric patterns, we don't like dividing, so we put it in terms of multiplying. So dividing by 3, that's the same as timesing by 1/3. Okay, so I could put divide by 3, but I should probably get in the habit of turning that 3 into a 1/3 and timesing by it. Because multiplying by the reciprocal is the same as dividing, right? If I divide by a 2/3, that's the same as timesing by a 3/2. Okay. So, just thought I would mention that. Alright, what about if we're dealing with a story problem? Okay, again, it comes down to what's my constant ratio, how is it growing, what's my 0 term, where does it start? So a population of rabbits doubles every 4 months. If the population starts out with 8 rabbits, how many rabbits will there be in 1 year? Okay, so we're looking more at making an equation, not so much answering the problem. So we start with 8 rabbits. It's my 0 term. Okay, And it says it doubles every 4 months. Well, what does double mean mathematically? It means timesing by 2. So we're timesing by 2, but we're doing it every 4 months. So there's 2 ways we can approach this problem. Okay. The easiest way would be to say, well, in the 0, right, we start with 8. In the first 4-month period, okay, this stands for 4 months, we double. So we times by 2 to get 16. In the second 4-month period, okay, we double again, so we get 32, and so on. So for that equation, easy enough, it's a sub n equals a sub n minus 1 times 2, and a sub 0 equals 8. Okay. However, if you wanted to look at growth monthly, okay, that's a little trickier. In that case, we're saying in this 4th month, that's when we actually doubled, so that would be 16. So the idea would be then, what am I actually multiplying by each month to get to 16? Okay, and that's a little weirder. I'll show you, but do it more the first way for now. Okay, if I go with where I started, okay, divided by 8 would be 2. Well, in 1, 2, 3, 4 months, I got to split that 2 into 4 pieces. Okay, so in other words, what times what times what times what would get me to double that? Okay. Okay, but we won't worry about that part so much right now. We'll just worry about it in this manner. Okay, we'll deal with that at a later time. Okay, so a certain type of bacteria doubles every hour. If you started with 36 bacteria, how many would you have after 10 hours? Okay, so, I guess in 1 year we would have had how many, right? That was 4, or 4 was 16. 8 months would have been 32, right? So 12 months would have been 64. So there'd be 64 rabbits in 1 year. Okay, so if you start with 36 bacteria, so we know our start number, our 0 term, is 36 bacteria. Okay, and how are they growing? What's the constant ratio? Well, doubling again. Remember, that means timesing by 2, so they're timesing by 2. So again, my formula, a sub n equals a sub n minus 1 times 2. A sub 0 equals 36. Okay, if I wanted to figure that out, first term would be, if we double 36, that would be 72. If we double 72, because we'd have to keep going until we get to 10, right? So I'd probably end up needing to use a calculator to help me out. So 72 times 2 is 144 times 2, 288 times 2, 576. That's 3, 4, 5, 6, 7, 8, 9, and then 10. Times that by 2, 1152. Times that by 2, 2304. After 7 hours, times that by 2, 4608. Times that by 2, 9216. Times that by 2, the 9th hour, we'd have 18,432. So then the 10th hour, so in other words, a sub 10 would equal 36,864. Okay? All right, now let's look at the next one. A soccer team. A soccer tournament starts out with 128 teams. After each round, half of the teams are eliminated. So kind of single elimination here, right? After 6 rounds, how many teams are left? So again, where did we start? We started with 128 teams. It says after each round, half of the teams are eliminated. So what that means is we are cutting things in half, also known as dividing by 2, or timesing by 1/2. We want to think in terms of timesing by 1/2. So my constant ratio I'm cutting things in half. I'm dividing by 2. So I go a sub n equals a sub n minus 1 times 1/2, and a sub 0 equals 128. Okay, and then to figure it out, right, we would have to track it. So at the 0, we start at 128. Then 1, we cut that in half, and that's 64. Okay, after the second round, there would now be 32 teams. After the third round, 16. After the fourth round, 8. After the fifth round, 4. So the sixth round would give us 2. Okay, so basically the seventh round, that's when we'd have our winner, right? That's how many rounds we could do. All right, so one more to take a look at. We like to use population a lot with these geometric patterns. So the population of a town is increasing by 5.5% per year. The current population is 15,000 people. What will the population be in 20 years? Okay, so the first thing to note is, where do we start? Okay, we start at 15,000 people. So what's our constant ratio? Now, they say it's 5.5%, which mathematically, right, is 0.055. The thing is, that's how much it's increasing by. Okay, so, but if I just go 15,000 times 0.055, that's only 825 people. So that's how many people it's going to grow by. But then the problem is you have to take this 0.055 and times it by 15,825 to get your next amount. So there's a better way to think through this. Okay, which you can do it that way, but here's a better way. Think of it this way. Okay, those 15,000 people, we're assuming that even though some people die, they're being replaced at 5%. 5.5% includes people dying and being born or people moving in, whatever. Okay, so we know that we're going to keep 15,000 because we're growing above the 5.5%. Well, 15,000 is like 100% of the people. So we're adding to those 100% of the people 5.5%, giving us 105.5%. So if we move the decimal, we're actually increasing by 1.055, which, if I take 15,000 and times by 1.055, we end up with, right, if I did a table, after that first year we have 15,825, which is what we said 825 was 0.055 of 15,000. So each time I'm multiplying here by 1.055. So my constant ratio is actually 1.055. So again, so that's kind of just a little trick you can use there. Okay, so a sub n equals a sub n minus 1 times 1.055, and a sub 0 equals 15,000. Okay, now if we really wanted to figure it out, we'd have to keep going, right? So, and then you're going to get some ugly decimals, so I'm just going to do it on my calculator, okay? And when we do it with our calculator to get down to 20 years, it should be about 43,766.4. So we count a fourth of a person, so about that much. Okay? All right, so you guys have got an assignment, so hand that assignment out. Get to work on it for a while. If you're struggling, need some help, try to do the best you can, and then take a look at the homework video, okay? So make sure you are working and get this done.